Chapter 4-8, complex numbers. This is yet another number system we have, just like the real numbers, the natural numbers, and the integers. We have now what we call the complex number system. The complex number system is a system that exists only to take the square root of a negative number. And the reason why is because we cannot take the square root of a negative number. So we have to formulate another way to do that. So the form of a complex number is a plus or minus bi. A plus or minus bi. Now, where a is going to be the real number and b is going to be the imaginary number. Here's the kicker. This is extremely important. If you get nothing else from this video today, get the I squared equals -1. I squared equals -1. So we're going to break this down into the number times -1 every time. So if I take the square root of -16, that's going to be 16 times -1. Well, what is -1? Well, -1 is I squared. So that's 16 times I squared. Now my question to you is 16 a perfect square? It is. That comes out as a 4. And what is the square root of I squared? That comes out as I to give you 4i. Now that's my answer. Let's do it again. Square root of -9. Well, 9 is a perfect square already, and -1 times 9 gives me -9. Well, -1 is I squared. And what is the square root of 9? That comes out as a 3. Square root of I squared comes out as a 3. I is my answer. And I think I just said the square root of I squared. That should be I. So, this is the nice, beautiful concept of it whenever it's nice and pretty. What happens if it's not so pretty? Because 18 is not a perfect square, is it? But we're going to go right back to this concept I just talked about. That concept is going to be that -18 is 18 times -1. Well, what's -1? I squared. Well, what's 18? Well, how do we break down that? Well, what are some perfect square factors of 18? Perfect square factors are 9 times 2. What's the square root of I squared? I. What's the square root of 9? 3. So that's going to give me 3i square root of 2. And that's how you do it whenever you have to break down the radical that's not a perfect square. One more time. Square root of -48. Well, again, that's going to give you -1 times 48. That's going to give you -1 turns into I squared. And 48? Well, what's 48 going to be? 48 is actually going to be 16 times 3. The square root of I squared is I. The square root of 16 is 4 to get me 4i square roots of 3. Okay, well now, how do we plot imaginary numbers? Well, let's say I had 3 minus 4i that I want to plot. Well, what happens is this becomes your real axis, your x-axis becomes your real axis, and then your y-axis becomes your imaginary axis. So very easy concept. If I want to plot 3, -4, I go over to the right 3 units on my real axis, and then I'm going to go down 4 units. 1, 2, 3, 4 on my imaginary. So here's the point, 3 minus 4i. Okay? If I have the point -7 plus 2i, that means I'm going to go over 7 units. 1, 2, 3, 4, 5, 6, 7 on my imaginary axis to the left, and I'm going to go up 2 units to give me -7 plus 2i. Very easy concept, no problems graphing there. Well, now we know something about a complex number. Again, what's a complex number? If you said a plus bi, that's absolutely correct, because a is the real and b is the imaginary part. Excellent. So now, adding those complex numbers. So if I'm adding complex numbers, well, this is ugly. It looks ugly. But what I want you to do is pretend that I is x in your head. Do not change on the paper though. So if I'm adding 2 of these, my question is, do I need these parentheses? I do not need the parentheses because I'm not distributing anything into this. I drop the parentheses, and I'm going to combine like terms. Well, my first like terms are going to be 9 and 23. Well, what is 9 and 23? It is going to be 32. And then I'm going to combine the 7i minus the 21i. And what does that give you? That's going to give you minus 14i. Very easy, right? You just simply drop it, pretend that's an x, and you combine like terms. CLT is the key here. Okay? This time I'm going to subtract complex numbers. So how do I subtract complex numbers? Well, my next question is, can I drop the parentheses? I cannot drop the parentheses because I am distributing. I have to distribute the minus sign. Okay? So that's going to be the same thing as 6 plus 9i plus negative 1 times 12 minus 13i. Meaning, I can drop the parentheses around the 6 plus 9i, but I distribute the negative into here to give me minus 12 plus 13i. At this point, I combine like terms. So I take my 6 and my negative 12 to give me negative 6. And then I'm going to take my 9, my 13i to give me 22i. Okay, so we've added, we've subtracted. Now what do you think I'm going to make you next? Yeah, I'm going to make you multiply. So if I'm multiplying, what is this going to be? This is going to be the distributive property. So 3 times 4 gives me 12i, that I has to tag along. And then 3 times 7 gives me minus 21, but I times I is I squared. But here's the kicker. I squared is equal to negative 1. So I have to substitute in what I squared is. So this gives me 12i minus 21 times the negative 1. Minus negative gives me a positive 21. And again, because I like a plus bi, I'm going to write this as 21 plus 12i. That's the distributive property. Now, clearly, this is going to be 2 binomials. So if I take 2 binomials, what do I need to do with those 2 binomials? Well, your gut instinct is again to pretend that that I is going to be an x. Very good. So now what do I do? If you said FOIL, all right. So first terms 4 times 3 is 12. Outer terms 4 times negative 7 gives me negative 28i. Inner terms 3i times 3 gives me 9i. And last terms 3i times minus 7i gives me plus minus 21i squared. Now, combine like terms. 12, negative 28, and 9 is going to give me a minus 19i minus 21i squared. But we have a problem because what is I squared? I squared is equal to negative 1. So I have to plug and chug what I know I squared to be. So if I plug that in, 12 minus 19i minus 21 times negative 1. Notice I only plugged it in for I squared. Not I, but I squared. So minus times a minus gives me a positive. And now I have like terms again. And that's going to give me 12 plus 21 is going to give me 33 minus 19i. And I like that. Why do I like that? Because it's in the form of a plus bi. That makes me happy. If you want to do the plus or minus, same concept there. Now, we've added, subtracted, multiplied. What's left? We're going to skip this one. What's left is dividing. So, denominators may not contain any radical expressions or imaginary numbers. Meaning, I cannot divide by an imaginary number. So how do I do this problem if I want to not divide by an imaginary number? Well, that means you have to multiply by what you need to multiply by what you need to eliminate the radical expression or the imaginary number. Keeping in mind that you're multiplying by value of 1. That value of 1 takes infinitely many forms. 5 over 5, x over x, 3 over 3. Or multiplying by 1 in this case can take on the form of something called a conjugate, which we will talk about here in a minute. Now, if I give you something that looks like this, I have 9 plus 12i divided by 3i. This just gives you one term that I'm dividing by, 3i. Now, what do I not like about this down here? What I don't like about this is I'm dividing by I. Well, what do I know about I? I just know I is I. But if I know I squared is equal to negative 1, and that means I want to change that I into an I squared. So I'm going to multiply this thing by a value of 1. And in this case, that 1 is going to take on the form of what I need to change that 3i into a 3i squared. So that's going to take the form of I divided by I. Why? Because I divided by I is 1. And 3i times I is going to give me 3i squared. So I'm going to put the parentheses on the top, distribute this, 9i plus 12i squared over 3i squared. 9i stays. I squared is going to give me what? A negative 1. Again, a negative 1. And what I have going on here is 9i plus a negative 12 over a negative 3. And if we divide each one of these terms by that, that's going to give me negative 3i plus 4 to give me the 4 minus the 3i. Now clearly, we could have done this much faster by just simply taking and making this into two fractions. But I wanted to show you what multiplying by 1 actually entails. So let's do this all over again. Notice 5 is not divisible by 3i, and neither is the 2 divisible by 3i. So what we need to do is multiply by a value of 1 again. And I need that 3i to turn into a 3i squared. So I need to multiply by what? If you said I over I, you're perfectly correct, because I'm now going to put parentheses around the top, and I'm going to distribute to give me 5i minus 2i squared over 3i squared. Again, what is I squared equal to? I squared is equal to negative 1. Remember I said if you get nothing from this today, understand that. To give me 5i minus 2 times negative 1 over 3 times negative 1. And this is going to give me 5i plus 2 over negative 3. And if I want you to make this an a plus bi form, that's going to be negative 2/3 plus 5i over 3. Same exact thing. I'm putting it and writing it as two separate fractions. Now what happens if I'm not dividing by just a number I? Okay, if I'm dividing by a binomial, for example this, I have to pull another card out of my trick book here. So what card am I going to pull out? I'm going to pull out what we call the conjugate card. Okay? So dividing by a complex number. To get rid of a complex number, you must multiply by the conjugate. Crazy teacher says, what? That's right, I said conjugate. Conjugate is a very important math term. What it is the real number system stays the same, but the imaginary sign changes. Okay? So, for example, if I give you a plus bi, the conjugate, oopsie, I cheated, forgot to erase this. Sorry guys. If I have a plus bi, its conjugate is going to be the a minus the bi. The real part stays the same. The imaginary, which is the bi, changed to minus bi. If I have minus b minus a minus bi, its conjugate is going to be, the real part stays the same. The conjugate of this is going to be plus bi. For example, if I have 3 minus 7i, the conjugate of this will be, the real part was 3, it stays. The conjugate, imaginary part, is minus 7i, so it turns into plus 7i. If I have negative 14 minus 3i, conjugate is going to be minus 14 stays, minus 3i turns into a positive 3i. So, conjugate is very easy. Another way to talk about conjugate, if I have 3 plus 2i is equal to, let's say, w. The conjugate would be 3 minus 2i, and we label that as w with a bar over top of it. That bar indicates that it is conjugate notation. Kind of important notation to remember. Okay, so here, I'm going to give you this one right here. 5 minus 2i over 3 plus 4i. How in the world do I do this problem? Well, I need to multiply by a value of 1. Why is it a value of 1? Always a value of 1. And since I have a binomial in the denominator, I'm going to ask myself, if I have 3 plus 4i, what is the conjugate of that? Well, the conjugate of that's going to be the real number stays the same, and the imaginary changes sign. So it's going to be 3 minus 4i. That is now what you're going to multiply by. So I have 5 minus 2i over 3 plus 4i times 3 minus 4i over 3 minus 4i. And then simply put parentheses around every single thing. What do you think you're going to do at the top? Marry them by multiplication. So you're going to FOIL. 5 times 3 is 15. 5 times 4 is minus 29. Inner is going to give me 2i times 3 gives me minus 6i. And last, minus 2i times minus 4i gives me positive 8i squared. Now, beautiful thing about conjugates, this is a beautiful thing, is when I FOIL. 3 times 3 is 9. 3 times minus 4 is going to give me negative 12. Inner is going to give you 4i times 3, which is going to be positive 12i. And last is going to be 4i times negative 4i, which is going to be minus 16i squared. What happens in the middle? Isn't it beautiful? The inner and outer cancel. Inner and outer cancel, only with conjugates, which means what happens is I'm going to have 15, 20i and minus 6i is going to give me 26i plus 8i squared over 9 minus 16i squared. Inner and outer always cancel with multiplying conjugates together, so all you have to do is do the first and the last term. But what we have to remember now is that our lovely little friend I squared is equal to negative 1, and I plug and chug what I know. And then I combine like terms. So this is 15 minus 26i minus 8 over 9 plus 16. So what's 15 minus 8? Well, it's going to give you 7 minus 26i on the top. And what's 9 plus 16? That gives you 25. So I would accept this answer, or in A plus or minus BI form. That's going to be 7 over 25 minus 26i over 25. That is what we're doing when you come back in here on class the next day. We're going to do a worksheet together to make sure that you understand. Any questions you have, you can Edmodo me, you can email me, and I will help you the best way that I can.